This video is on Unit 1, Chapter 1, Lesson number 3. Lesson number 3 is on solving equations. On the notes, the guided notes page here, on the left, you can see that we have some steps to solving these equations. The basic steps to follow are outlined, and number 1 says to distribute. Step number 2 says to simplify each side by combining like terms. Step number 3 says move your variables to one side. And then step number 4 says solve using inverse operations. So I'm going to look at example number 1. In example number 1, again, the directions here just say to solve each equation below. So for number 1, we're going to distribute the 6 into the parentheses. So 6 times n is 6n. 6 times 5, and look left, it's a positive 5, which is going to give us plus 30, is equal to 2. So that's step number 1. Step number 2 is to simplify each side by combining like terms. Well, 6n plus 30 will not combine because they are not alike. So I can move on to step number 3, and it says move variables to one side. If you'll notice, you've got 6n plus 30 is equal to 2. Your variables on the left, there's no variables on the other side. So I would personally move the 30 first. And we're going to do that by using opposite operations. It says plus 30, so we're going to subtract the 30 from both sides in order to isolate that variable. 2 minus 30 is negative 28. Divided by 6. Negative 28 divided by 6. If you stick that in your calculator, you're going to soon find out that that does not go evenly. FYI, I do prefer fractions over decimals. That will reduce to negative 14 thirds. Let's jump to example number 2. In example number 2, you have to distribute, but you also have this fraction bar. So the way that I would recommend you tackling the fraction bar is to get rid of it first. So the bar indicates division. We're dividing by a negative 4, and I would undo that first. How do we undo dividing by a negative 4? Well, we multiply by a negative 4. So I'm going to multiply by a negative 4 on the right, and I'm going to multiply by a negative 4 on the left. And what happens is the negative 4s cancel each other out on the left. They divide each other away. So I'm left with 3 times 5 minus 3x is equal to negative 15 times negative 4 is going to be a positive 60. So that's not really a step in the basic steps to follow when you've got a big fraction bar like that. That's why I wanted to start you out on that example. I'm not going to finish it because there are others that are a little more complicated. If you want to finish it out, you can. I will tell you that the answer is x equals negative 5. Jumping down to number 3. We've got 2 times 2 minus 7y minus 5 is equal to 111. The reason why I want to show you this one is because you've got more than just a couple of things on one side. Step number 1 is still going to be to distribute here. 2 times 2 is 4. 2 times negative 7y is a negative 14y. Minus 5 equals the 111. So step number 2 talks about simplifying each side by combining like terms. And in this equation or this problem, you have like terms. And I've underlined them in red so that you'll look at those two numbers. They are like terms, and we can put them together on the left side. Follow exactly what it says. It says 4, look left, minus 5. 4 minus 5 is a negative 1. Bring down the minus 14y equals the 111. Then I'm going to get rid of the negative 1 by adding a 1 to both sides. and negative 14y is equal to 112. Then we're going to divide both sides by that negative 14, because that's the opposite of multiplying, and you get y equals negative 8. Example number 4 is almost identical to example number 1. The only difference is you've got fractions, and you're just going to do that in a calculator. Most of you are going to multiply those out in the calculator. Let me pull up my calculator really quick. So the problem here is still going to, we need to distribute first step. We need to distribute negative 15/16 times 4/5 cube and negative 15/16 through to the positive 32/3. So let me show you how to do that in the calculator. Negative 15/16, we're going to go to alpha y equal and pull up a fraction. Negative 15 over 16. We're going to multiply that times 4/5. So alpha y equal, bring up a fraction, 4 over 5, and it's going to spit out negative 3/4 q. So I got negative 3/4 q. And then negative 15/16 times 32/3. Alpha y equal negative 15/16 times 32/3. And we get negative 10. So minus 10. From there, I would add the 10. Negative 16 plus 10 is negative 6. And then most of you are probably going to divide by the negative 3/4. So negative 6 divided by negative 3/4. Negative 6 divided by alpha y equal negative 3 over 4. And we get a positive 8. So q equals 8. Let me jump down to number 8. Jumping down to number 8. First step is to distribute. There is a minus here directly in front of the parentheses, so I would like to remind you to distribute that negative 1. So we have 16, negative 1 times 7m is negative 7m. Negative 1 times positive 3 is a negative 3, equals, distribute the 8, 8 minus 8m. Step number 2 again says to simplify each side by combining like terms. On the left, we have like terms. 16 minus 3 is 13. And then on the right, we got 8 minus 8m. So at this point, what you should notice is you've got numbers and variables on both sides, and you need to pick which side do you want your variables and which side do you want your numbers, because they need to be on opposite sides. I am personally going to add an 8m. That doesn't mean that you have to add the 8m, but that's what I'm going to do. I'm going to add the 8m so that the 8m goes away on the right side. And I'm going to combine my negative 7m plus 8m and get a positive 1m, or just m, equals 8. Now you can see easily that we need to subtract the 13. And we get m equals negative 5. All right, moving on. Number 9 is very similar to example number 2. I'm going to go ahead and start this one really quick, I would for sure multiply both sides by that denominator. So you've got that big giant fraction that needs to be your first step. So I'm going to multiply by 2 on the left. Now, the reason why I'm showing you this example is because the right side is not just a plain number like it was in example number 2. You have a binomial on the right side, which means when we multiply that side by 2, we are going to need to distribute. So that becomes 6x plus 2. And I'm going to bring this other numerator down. Actually, I'm going to distribute that -1 as well. Negative x plus 9. So again, there was a -1 in front of that parentheses. And as I brought it down, I went ahead and distributed that, -1. Now I'm going to combine like terms on the left. 10x minus x are alike. So 10x minus x is a 9x. Positive 17 plus 9 are also like terms. So 17 plus 9 is a positive 26. Here again, we have variables and numbers on both sides, so you need to decide where you want to go with this. I'm personally going to subtract 6x. 9x minus 6x is 3x. And now I'm going to subtract the 26. So I got 3x equals 2 minus 26 is a -24. And then we need to divide both sides by 3. And you get x equals -8. I've kind of run out of room there. All right, we want to talk about special cases. So with special cases, your variables are going to subtract out. And you're going to be left with either a true statement, which means our answer is all reals, or a false statement, which means our answer is no solution, meaning nothing works. So let's look at both 11 and 12. In number 11, to start this out, I'm going to distribute my 5. 5 times 1 is 5, minus 5 times c is 5c, plus 8c. The right side of this, to me, just looks funky. There's too much going on, which immediately makes me realize that I've got like terms. So I'm going to combine the -5c plus 8c. -5 plus 8 is a positive 3c. Now what I want to do is I'm going to subtract this 3c. And what happens is the variables both cancel on both sides. But what I have left says 1 equals 5. Well, 1 never equals 5. So that's what tells me that that's no solution. That is my answer. There is no answer. It's a no solution. On number 12, to do this one, we're going to start out with distributive property. -8 times x is a -8x, and -8 times a -5 is a positive 40. So from there, I'm going to add 8x. And again, what happens is your variables subtract out on both sides of the equation. But if you look at what's left, that's true. Because that's true, my solution is all real numbers. In the next set of examples, we're talking about proportions. And with proportions, what you need to know is that cross products are equal. So we're going to use cross products to solve these. In example number 13, I'm going to multiply the 5 times the x plus 4 and the 3 times the 2, which is 6. And because cross products are equal, I can make that into an equation that I know how to solve. To finish that off, we would distribute 5 times x is 5x. 5 times 4 is 20 equals 6. And then you should be able to solve that from there. Subtract the 20. 6 minus 20 is a negative 14. And then we're going to divide both sides by the 5. Now, with this one, negative 14 divided by 5 does not reduce. You can try to do negative 14 fifths. It doesn't reduce. And again, I do not like decimal answers. I will let you know when it is okay to give me decimal answers, but as a general rule, we do not use decimals in Algebra 2. So x is equal to negative 14 fifths. Number 14 would be very similar. If you work it out and you're curious, x is equal to negative 2 fifths. I'm going to move on to the next set of examples, which is on literal equations. Literal equations are equations with a multitude of different variables, and you're going to be asked to solve for one specific variable. So the directions here say to solve each equation or formula for the specified variable. So if you look at example number 15, it says C is equal to 2 pi r. And over on the right, it's telling me I'm supposed to solve that for pi, meaning that when I'm done, it should say pi equals something. Everything else should be on the other side. Y'all, the key to this is opposite operations. The key to this, again, is opposite operations. So if I want to get pi by itself, so this says C is equal to 2 times pi times r. That's what that says. If I'm trying to get pi by itself, I'm going to put a little box around it. Then I'm trying to get rid of the 2 and I'm trying to get rid of the r. Okay? Well, the operation that's going on there is multiplication. How do we undo multiplication? We undo multiplication with division. So if I divide over here by a 2 and an r, what happens is the 2's cancel and the r's cancel. So I'm going to do the same exact thing on the left, and it's going to be C over 2r is equal to pi, and that's your answer. Pi is equal to C divided by 2r. I'd like to look at example number 16 because it does involve a fraction. And fractions with literal equations are a little tricky. They are a little more complicated. So this is A is equal to 1/2 times A times P. And I'm trying to get the P by itself. I know I need to divide by the A. The little a. That goes away and that goes away. So I have A over A is equal to 1/2 P. And a little bit ago, in one of the previous examples, I just divided by the fraction. Well, with literal equations, you can't really do that. What you need to do is multiply by the reciprocal. So reciprocal means flip the fraction. I'm going to multiply by 2 on both sides, and what happens, because a 2 is a whole, and that 2 in the fraction is in the denominator, those two things are going to cancel. So I have a 2 times A over A is equal to P. Let me write that. Little confusing. We may have to work on that in class. Let's look at number 17. A plus B over C is equal to 5. This is very similar to some of the others that we've seen so far. We're trying to get B by itself, and you've got a big fraction. So we've got to get rid of the big fraction first. We're going to multiply both sides by C, so that fraction now goes away. I have A plus B is equal to 5C, and I'm trying to get the B by itself. Now, at this point, I need to get rid of the A. Well, what's happening with the A? It's A plus B. It's a positive A. So in order to get rid of this A, I'm going to have to subtract. You've got to think about opposite operations, how to undo, how to get rid of. So that's me for the notes. That's the notes for this lesson, lesson number 3 on solving equations. Again, we will work on the assignment portion of this together in class. Let me know if you have any questions.